Okay, so last week we talked about what a relation was, right? And we know that a relation is what? A set of ordered pairs. So anytime that you see ordered pairs, you have a relation. And we've seen that a lot in algebra or in math in general. But there's a special relation where when the x's or the domain does not repeat, we call that a function. So we need to be able to look at all of the ways a function is written and tell, is it a function or is it not a function? So on this paper is a couple of different scenarios. The first set, what kind of version is this? These are tables. And what we're going to do is we are going to look at all of the x values. Do you have any that repeat?
Yes.
Yes, which ones? -3. So no, this is not a function. We go to the second one. Does anything repeat? No. So then it is a function. What about C? -6 repeats. So no, it's not a function. And then the last table? Nothing repeats, so yes it is. So when you're looking at a table, it is that simple to determine if it's a function. Now the second type is this. What is this called? It's just ordered pairs. It's a list, right? They just basically listed the ordered pairs. So the strategy is to just look at the x's. And usually what I do is I will circle them and I'll say, did any of them repeat? Yes. So this is not a function. And then I do the same thing here. For some reason, when you actually circle them or underline them, it's like a visual for your brain. So does this one repeat? No. So then yes, it is a function. Then we also learned the correct way to list the domain and the range. Remember, domain are all your x's and the range are all your y's. So we put the D colon and we put a brace. Let's do this first one as the example. So what are the domain values? -3. We don't have to repeat it twice. 2 and 4. And then we close it. And for the range, we do the exact same thing. So the value of the y's are -2. And now we know how to list both of them if we have to break them apart. Then we also learned where if we have a graph, we use what? The ruler thing, which is called the vertical line test. Now, it is important that you know the term vertical line test, because if on an exam or a test they ask you, is this a function? You would say, yes, this is a function because it passes the vertical line test. Now, the vertical line test is where we take the ruler and we travel across the actual graphed line or shape, and if it only touches in one location anywhere on the graph, then yes, it is a function. Okay, so let's do the second one. What about this one? Yes, it is a curve, so we know that one is. What about this one that's sideways? No. Look at the two spots it hits, here and here, so no. What about this one? Yes. And what about this one? Yes. And then what about this one? No. The circle, the closed figures are always your best example of not a function. What are other ways that we learned? There was another way that we learned as well. Mapping. And mapping is basically just two circles that look like this. This is what we call mapping. And we can basically label our x's here and then our y's here, and we connect. So if we're looking at this one right here, this one is not a function because the -3 is used twice in the mapping. Okay? Then what are some other ways? There was 2 other ways that we talked about. What's another way you might have to look at and determine if it's a function? Well, we got a table, we've got a list, we've got mapping, we've got graphs. Equations, very good. Y equals mx plus b. We need to be able to determine if that is a function or not, which we know it is because it's a straight line, correct? So you could take an equation and make a graph of it and then determine, is it a function or not? And then word problems. We know how to write a word problem into an equation or put it in a graph. And that's how you determine, is it a function or not?